this problem, we need to find the critical points of the function. We need to find where the function is increasing and or decreasing. We need to state what the extrema are. So we need to find the maximum or minimum. To do this, we need to do the first derivative test. To do the first derivative test, we have to first take the derivative. So g prime of x is pretty straightforward. We have 3x squared minus 10x minus 8. And we set this equal to 0. This is how we find our critical numbers, setting this equal to 0. To solve, we have a 3-part trinomial, so we are going to have to factor this. Since we have a 3 in the front, you can use whatever method you want, but this would be a case that you would use fake factoring if that's what you use. So the 3 will be in the front both places. The x squared will still be split up into x and x. But with fake factoring, you need to multiply the 3 and 8, and we are looking for factors of 24 that can subtract to 10. Okay, so we are looking, we have 1 and 24, we have 2 and 12, we have 3 and 8, we have 4 and 6. So let's look at these 4. No way it's going to be 1 and 24. Could be 2 and 12. It's not going to be 3 and 8. And 4 and 6, if I add them, I would get 10. But remember, I need to subtract to get 10 because they need to be opposite signs so I can multiply to a negative 8. So 4 and 6 don't work. So I will use 2 and 12. I need a negative 10, so the 12 will be negative and the 2 will be positive. Don't forget your last step of fake factoring is dividing out what each factor has in common. 3 and 2 don't have anything in common. 3 and 12 have 3 in common. So my final factors are 3x plus 2 and x minus 4. This leads my critical numbers. So here are my critical numbers are x equals negative 2 over 3 and positive 4. My critical numbers. Okay. From here, we take these critical numbers and put them on a number line because we need to use our first derivative test. I don't know why that happened, so let's fix that. We need to use our first derivative test, okay, to figure out where we're increasing, decreasing, finding our extrema. So we are going to put negative 2/3 and 4 on our number line. Our first derivative test includes finding numbers, choosing numbers on this number line that are not our critical numbers that we test to figure out what the sign is. So I do suggest that you write these numbers in a different place than your critical numbers. Don't make them look like critical numbers because then you'll get them confused and you might get your answer wrong. I leave my critical numbers on the bottom and then I put the test numbers that I'm going to plug into the derivative because it's a derivative test. I'm going to put my test numbers on the top and I'm going to circle them. I'm going to use -1 for this area here. I'm going to use 0 for this area here. And I will use 5 for this area here. So I put them on the top and circled them so that I know that I will be done with them after I plug them into the derivative. So you can plug them into either part of your derivative, either the unfactored form or the factored form. When we plug in -1, we get 3 times -1 plus 2, which is -3 plus 2, which is -1, times a -5. We will get a positive number. When you plug in 0, you have 2 times -4, which is a negative number. And when you plug in 5, you will get a positive number times a positive number. sorry about that announcement. So what I was saying is that when you plug in 5, you will have a positive number times a positive number, which gives you a positive number. So we figure out where this is increasing and decreasing, and we can answer the second part of our problem. Where our derivative is positive, our original function is increasing. Where our derivative is negative, our original function is decreasing. And again, where our derivative is positive, our original function is increasing. So here are increasing and decreasing intervals. So we can go ahead and write these. Increasing, we have two intervals that are increasing. From negative infinity, we use a parentheses because negative infinity is not a number we can include. Negative infinity to negative 2/3. We can include 2/3, it is a number. Union, it starts increasing again at 4. We can include 4, it is a number that we can choose and it is part of our domain. So we're going to go to infinity here. Then decreasing, there's only one section where it's decreasing, right in the middle. So in between negative 2/3 and 4. And we're mostly done with this problem. We just need to identify where our maximums and minimums are happening. A maximum happens when our derivative changes from positive to negative, and a minimum happens where our derivative changes from a negative to a positive. We have both of these happening here. On this side, we have positive to negative. This would be a maximum. And on this side, we have negative to positive. This would be a minimum. We already know our x values of our maximums and minimums. The maximum, the x value is negative 2/3. And the minimum, the x value is 4. So we need to plug these in. If you do this without a calculator, you will have 4 cubed minus 5 times 4 squared minus 8 times 4. Plugging this into the original equation now to find our y values. Okay, so when you add all this up, you will get a negative 48. So that is our maximum value. Oh, minimum value. Put that in the wrong spot. That goes over here. Negative 48 is our minimum y value. Now we need to plug in. We have negative 2/3 cubed minus 5 times negative 2/3 squared minus 8 times negative 2/3. So to square or cube a fraction, you're going to cube or square the top and the bottom. Negative 2 cubed is negative 8/27 minus negative 2 squared is 4, and this is 5/1. So we have 5 times 4, which is 20. This is over 9, because 3 squared is 9. Minus, we have 8/1. Negative 8 times negative 2 is a positive 16/3. We need these to have common denominators. So this is a review of just regular algebra, okay? So we do need these numbers to be the same to add them up. 27, all these numbers go into 27, so I need to multiply the top and bottom of this by 3, the top and bottom of this by 9. That will give me negative 8/27 minus 60/27 plus 144/27. When I'm adding fractions, the bottom will stay the same. So my denominator is still 27. 8 minus 60 plus 144 is not 116. I did that wrong on my paper. So if you take a second and pull up your calculator, make sure we do this right. We have negative 8 minus 60 plus 144. we'll get a positive 76, which is not divisible by 3, so we can't reduce that fraction anymore. So this is our y value for the maximum, 76 over 27. And there are our answers. We have our increasing and decreasing, we have our max and min, and up here we identified what our two critical numbers were.